What existed before the Big Bang? It sounds like a simple question, but in reality, it may be one of the hardest questions in all of science. Our minds naturally assume that every beginning must come from something before it. Every story has a previous chapter. Every event has a cause. So if the universe began with the Big Bang, what caused that beginning? To answer that, we first need to understand what the Big Bang actually was. Most people picture it as a giant explosion happening somewhere in empty space, like matter suddenly bursting outward into darkness. But scientifically, that image is misleading. The Big Bang was not an explosion inside space. It was the expansion of space itself. Around 13.8 billion years ago, the observable universe existed in an incredibly hot, dense state, and then space-time began expanding. We know this because of several major scientific observations. First, distant galaxies are moving away from us, shown through redshift. Edwin Hubble discovered that the farther galaxies are, the faster they appear to recede, suggesting that space itself is expanding. Second, the cosmic microwave background radiation acts like leftover heat from the early universe, a faint signal still detectable today. Third, the abundance of light elements like hydrogen and helium matches predictions from models of the early universe. Together, these observations strongly support the idea that the universe was once much smaller, hotter, and denser. But here's where things get strange. The Big Bang theory explains how the universe evolved from an early hot, dense state. It does not necessarily explain the absolute origin of existence itself. When physicists mathematically rewind cosmic expansion backward, the universe appears to approach a state of infinite density and temperature called a singularity. But singularities are often signs that our equations have broken down, not necessarily that we've discovered the true beginning. In other words, our current physics may simply stop working under such extreme conditions. This is where Einstein's theory of general relativity becomes crucial. According to relativity, space and time are not separate. They are part of one unified structure called space-time. So if the Big Bang was the beginning of space-time, then time itself may have started there too. And if time began at the Big Bang, then asking what happened before, it may not make scientific sense at all. A useful analogy is asking, what is north of the North Pole? North only applies up to a certain boundary. Beyond that, the question itself breaks down. Similarly, if time itself started with the universe, then before may not be a hidden era we haven't discovered. It may simply be a meaningless concept. But physics doesn't stop there. Quantum mechanics introduces an entirely different perspective. In everyday thinking, nothing means complete emptiness. No matter, no energy, no space. But in quantum field theory, even vacuum space is not truly empty. It contains fluctuating energy fields, and particles can briefly appear and disappear. This means what we call nothing may actually be a dynamic quantum state. Some physicists suggest our universe may have emerged from such a quantum fluctuation. In this model, a tiny quantum event could have triggered cosmic inflation, a rapid, exponential expansion that produced the observable universe. Other theories propose alternatives. Big bounce models suggest our universe may have been preceded by a previous universe that collapsed and then rebounded. Eternal inflation suggests our universe may be one bubble in a much larger multiverse where countless universes constantly form. String theory and brain cosmology even suggest that collisions between higher dimensional structures may have created Big Bang-like events. The biggest challenge is that modern physics still lacks a complete theory of quantum gravity, one that successfully combines general relativity and quantum mechanics. Without it, we cannot fully describe the earliest possible moment. So what existed before the Big Bang? Right now, science offers possibilities, not certainty. Maybe time itself began there, so before doesn't apply. Maybe a quantum vacuum triggered creation. Maybe another universe came first. Or maybe our universe is only one part of a far larger reality. The truth is, we still don't know. But that uncertainty is exactly what makes this question so powerful. It doesn't just challenge our understanding of the universe, It challenges our understanding of reality itself. Because when we ask what came before everything, we are really asking whether existence has an ultimate beginning, or whether the true nature of reality is far stranger than human intuition was ever designed to understand.